All right, Hong Kong students, I see you again today. Our focus for today is to talk something about the Michael Super World War, World One metals. Okay, with that. While for the last double lesson, this is for this Friday, we'll go over with you on titrations, titration is not the one, acid and alkali, preparation of salt, and qualitative analysis. Okay, so and indeed, it is the cover of those questions, right, on your exam. It is on this. So we refer to this. If you classify those questions into different categories, you may find the following. First of all, this is what we call it as a periodic table. Can you see this? So I just want to make it clear. What is that? Oh, why? How come? I still cannot write anything on that. Oh, I see. Oh, that is the reason. Is it? Let me see if that is the reason. Is it? No. Strange. Sorry about that because I need to double check. How come I cannot draw? Is it a matter of the formats? Or just like last time I used PDF again? Anyway, PDF then. Oh, I don't know why it's so strange. Every time it's not all the documents we can use Word to directly write something on it. I don't know why. Now, if every one of you have arrived, I will start the lesson now. And let me take a quick look on your attendance first of all. All right, all of you here, right? So, as said before, please finish this one, okay? You should have finished, right? So, according to this, this is a very long paper because it's 2 hours. But for half exam, it's just 1 hour, 30 minutes. So, I would like to tell to you what was that. In short, for question 1 is something about periodic table. 2, it is bonding and structure. And 3, metals. And empirical formula. 4, rustic. 5, mole-cal. Okay, so today our focus is on that 5 questions. Okay, how about the other? From number 6 to number 11 is exactly acid and alkali, and preparation of salt, etc. So you will see that. Second, do you realize we have got some asterisk, some star here, right? What is meaning? The star, they represent there is effective communication in success. In other words, it is an essay type question. Okay, do you understand? So this is what I would like to draw attention to the questions. Now you go to this question 1. What is the relative abundance of bromine 79? A very authentic questions. So what you need to do is to first of all write down the following, right? To let something. Now there are 2 ways to let something. So you're going to let y% be the relative abundance of bromine 79. Now it is different when you are going to let X be the relative abundance of bromine 79. Do you know the difference? It's not the letter X and Y, but also the word percent. How does it affect the value? Do you know? So if I use the Y%, which means that you are going to have 79 for the first isotope times Y%, okay, plus 81 times 100 minus Y%. Can you get the point? Equals 79.9. So we'll get the answer. Y is about 50.0. So you may get the relative abundance of bromine 79 is 55.0%. But if you use another method, use X as an example, so the calculation will be changed to 79x, okay, plus what? 81 bracket 1 minus x equals 79.9. You can do something similar, but the x value will change to what? 0.550. So by using this method, the relative abundance of bromine 79 will become arrayed as still 55.0%, but the way to present is a little bit different. For the first case, on the left-hand side, y should represent the number from 0 to 100. Can you get my point? While for this x, the minimum number is 0, the maximum number is just 1. So this is what I would like to draw attention. But anyway, either method would help you arrive at the answer. So for the last sentence, you need to write here clearly. Only by doing so you can get 2 marks. Questions? Questions? So for first mark, what is that? First mark will be on this. Second mark will be on this. Is that clear? Now here comes question 2. Is it possible to separate the isotopes of bromine by chemical method? Explain your answer. So you are going to tell is or is not, and second, give me the reason. So what happened to this? The answer is no, right? Why? No, what is the reason behind why is it no? Tom Quan Nhật. Tom Quan Nhật.
係
呢個答 no 啊嘛，咁點解 no 啊？ They have the same electronic configuration, the same chemical property, same number of electrons, right? Okay, so we have got the similar answer, right? So, but most of the time you talk about isotopes, they have the same number of 喂，頭先有你答係咁就點啫 ？electrons. So, or you talk about they have. So what is that? They would have the same electronic arrangements. So what is the hidden message? They have exactly the same chemical property. Can you get my point? So this is this needed the same number of electrons. So they have the same electronic arrangement. Okay. So they have, as a result, thus they have identical or the same chemical property. So it is not possible to separate them by chemical means. Is that clear? So we have got 2 marks. The first mark, you are going to tell me yes or no. Okay? And second, you are going to tell not possible, same number of electrons or the same electronic arrangement, either one of them. Okay? But you have to address to this part, same chemical property, before you score that full. That is the key point. Okay? Questions? Now here comes question 3. Explain why the boiling points of halogens increase down the road. What does it mean by increase down the road? Is from fluorine, chlorine, bromine, iodine. So the boiling point increase. So that is a trend. You're going to give me reason why. So again, the way to solve is to relate the following. Okay. So how does the boiling point of the halogen depend on? Yes, the strength of intermolecular force. So what you are going to compare is to compare the size. So the first thing that I would like you guys to pay attention to is to write down halogens. All halogens, they have the same structure. What is that? Simple molecular structure. So the intermolecular force in halogens, they are van der Waals force. Now, I would like to draw attention, right, to write down what is meant by van der Waals. Okay, VANDER WALS. The spelling should be noted. So as the number of electrons in the halogens increase down the group, or somebody would love to replace this term by telling it as molecular size increase down the group. Okay, so the strength of van der Waals force between halogens molecules will happen, will become stronger, right? Also increase down the group. So what is the hidden message? You need, because you are relating to boiling point, so you are required to use heat to overcome the attraction force between the molecules during boiling. So the boiling point of halogens increase down the group. Do you still remember that? So what are the key points? First of all, point number one, you need to tell me intermolecular force that will affect the boiling point of halogens. Two, you are going to tell me the in simple molecular force, simple molecular structure about the van der Waals force that holds the halogen, right? So you get that mark, okay? You'll get that mark altogether. So as the strength, as the size of molecules increase down the group, the strength of it increase. So we have got that too. So more heat is related to overcome attraction force. So the boiling point increase. So what you will see in red, I highlighted in red, will be the main focus. Okay, will be the main focus on your on this question. Any doubts? Anything that you want to ask? Now I would like to check somebody who just write down something. Molecular size increases under strength. Yes, that's right. So you may get the Justin's work is correct. Size increase, strength increase, more energy. So, but before that, you need to tell me what are the income. What are the main ground of comparison? Is that they have the same structure, simple molecular structure, while the molecules that hold them together is van der Waals force, and you're going to compare the strength of van der Waals force. Okay, so let's just say you just miss out this point, and afterwards you may find it's nice. So you may get this. Questions? In short, what is the meaning? The meaning is that the molecular size will affect the strength of van der Waals force that would affect what? The physical property. So boiling point is one of the example. Okay, questions? Now, if not, you may come to question 2. Now, for question 2, the diagram that shows the partial structure of 3 substances A, B, and C. Now, remember to note that at room temperature and pressure, so suggest the substance has the same structure as A. What can be A? What can be A?
Iodine.
Iodine, yes, that's right. Can it be chlorine?
Yes.
Why?
I don't know. So Halo.
You say that you don't know.
Both of them are halogens, so both of them have the same structure.
You think of it as string structure. So chlorine is also possible. Agree? All of you agree? How about Hongming? Saris? Hongming?
Yes.
Yeah? Yes. Yeah? Tell me.
Iodine solid.
Mm-hmm.
Yeah, same answer.
So you mean, how about chlorine? What I want to tell you is chlorine. Is chlorine possible?
No.
Why not?
In room temperature, is it? I think it's no.
Mm.
Because chlorine gas in room temperature. Chlorine is gas in room temperature.
Yeah, chlorine gas room temperature is wrong. Okay, you get my point. So similarly, bromine cannot be the answer, right? So you may think of acetylene if you can spell the word correctly. Acetylene is also a solid. So it's for A. Remember, this diatomic, but never is oxygen. Oxygen, no. Can you get my point? Nitrogen, no. Hydrogen, no. Because at room temperature and pressure, you may find this one, it is a regular arrangement. So according to Form 1, I guess that you know that those particles, they are arranged regularly. We are now referring to solid. So you are going to only name this as a solid as the answer. So 2 points. Number 1, solid at room temperature and pressure. 2 is diatomic. So for B, if B and C represent silicon dioxide and NaBr, identify particles M and N. So what is M? So what is N? Once again, so what is M and N? Once again, where are you?
M is carbon.
M is carbon.
And N
This is carbon, right?
Yes.
So take a look on B. What is that? B, it is silicon dioxide with a formula SiO2. Sodium bromide is C with a formula NaBr. We start from this. Try that again. There's nothing not correct. Your answer not correct. Is it carbon? Do you have any carbon here?
我睇錯咗，sorry。
係啊。So you can split that two with that particle into two. We have got silicon atom and oxygen atom respectively. While for sodium bromide, we have got 2 types of particles. This is sodium ion and bromide ion. So you are going to have a matching of the two. Okay, you get my point. So this one is, the black one is oxygen atom. Why? But not silicon. How do you know? M, it is oxygen atom. You're going to check what the bonding environment, right? Can you see that? Now for oxygen, now it's quite hard to take a look from this. How about this? Now we have got 2 single bonds. Okay, 2 single bonds. So which means that it is in group 6, right? 2 more electrons for it to become octet. How about that? The other bond is silicon because we have got 4 bonds. You know, we have got 4 bonds. 1, 2, 3, 4. So this one is in group 4. So it is silicon. So this is for B part. How about C? So we have got sodium ion and bromide in 1-to-1 mole ratio. So somebody will think that you may choose either one as the answer. Correct? But it's not correct. You are going to compare the size of particle to tell which is which. Sodium ion and bromide, which one is larger? The one is larger, that is the answer. N is what? Bromide ion. Can you get the point? It's not sodium ion. It's not sodium atom. Can you get my point? Why? Why do I know that? How do I know bromide ion is larger? Which period does it belong to? Which period? For bromine to bromide. 1, 2, 3, 4. 4.
係咪 3啊？係咪？
Yeah, you occupy 4 electron shells for bromide. Fully occupied 4 shells. How about sodium? Sodium ion, how
係
many?
third，好似係 third 係嘛
有幾多層啊
？3層。
3層就錯啦 ，sodium ion 係嘛 ？Just 2. Why? 2H. The electronic arrangement for sodium is 2H, not 2H1. Okay, just two shells occupied. Well, how about this? 4 shells occupied. 明唔明？所以 you may know N is larger. Larger size bromide. C, comment on the following. The electrical conductivity of A when it's molten. The surface of B water at room temperature pressure. Comment on. 識唔識答？ So first of all, you go back to the structure. A, what is that? A, what structure does it have? A, they have the simple molecular structure. Okay, so you need to tell me molecules. They are held by van der Waals force. Okay, how about molten? What happened? When A is molten, what happened? Electrical conductivity. There are mobile ions, non-delocalized electrons. So what happened to A? It does not conduct electricity. Okay, so this is what you want to comment on. How about B? Solubility of B water at room temperature pressure. Is it not soluble in water? Silicon dioxide. No. Okay, why not? Again, do you find that very often for the first question, first sentence, you need to mention it is the bonding in the structure, right? Giant covalent structure, while the atoms, they are held together by strong what? Covalent bond. So do you realize that this is always written like this? It's always written like this way. Okay, so what happened to how do you relate to the solubility of water? 你見唔見到萬能 key 啊？即係呢句説話，成日咧講緊佢有乜嘢都好咧，你哋都要寫翻呢句嘅，就係咩 bonding 咩 bonding structure 係咪？跟住啲 atom 啊粒子有咩嘢連住？呢個係成日問嘅。咁下一句咧就關鍵啦嚇，佢問你咩啊？你就點樣諗翻佢唔同嘅啲solubility the weak intermolecular force between the water molecules. They are too weak. They are too weak. In other words, we say that they are not strong enough to what? Overcome the what? The covalent bond.
In the structure.
Yeah, the strong covalent bond between the atoms in B. So B is water insoluble. 明明通常我哋寫 bonding structure 個寫法就係咁啦。So we start with a sentence telling the others the bonding structure. So remember to identify particles and what is the attraction force between the particles. Point number one. Point number two, you are going to relate to the bonding environment to the physical phenomenon. How to account for example, electrical conductivity, good or bad, or maybe solubility, is water soluble or not? 明唔明？要諗翻呢兩句説話嘅 questions. Now here comes this. Both cesium and sodium, they are group 1 elements. Explain why the compound formed between these cesium bromine as a foreign structure rather than the structure of C. Now this is cesium bromide. Now if you take a look on this structure, when you compare with C, they are not the same. They are not the same. Why? Now cesium and bromine, they are also in group 1. So according to the ratio, this must be 1 to 1. But how come the packing structure it comes to differently? What is the difference? What is the difference? Tanjay, what is the difference? Between sodium ion and cesium ion. So what is the difference? First of all, what are they similar is they belong to group 1. The charge is also +1, but what is the difference? The atomic size, somebody says that, change a little bit, twist a little bit. It's not atom. You're going to talk about ionic size. Which one is larger? Okay, you get the point. CCM is bigger. So in the structure of cesium bromide, what happened? Cesium ion is surrounded by how many? H bromide ion. While in sodium bromide, each sodium ion is surrounded by 6 bromide ion. So it's different. So remember, once again, let me tell you the size of ion is a point of comparison. Size of ion, but not size of atom. And second, because of size ratio, they are different. You cannot, so just recall your memory about this structure. For the black one, it's very small. It seems like a smaller ball that embedded in between, is put in between the holes between the 2 large atoms. So this one is will have a more densely packed structure when you compare with this. But for cesium ion and bromide ion, the size of them, they are more or less comparable. How do I know? I'll take a look on periodic table. Cesium ion, what does that group? What period does it belong to? 1, 2, 3, 4, 5, 6. 5 occupied electron shell. But for bromide, it's just 4 occupied electron shell. Okay, when you compare with sodium bromide, the difference in size is different. So these two, they are more or less more comparable in size. So you cannot use this to relate to sodium ion. It seems like embedded inside. Instead, it would make the space between the bromide and larger. So we cannot tell it having the same packing structure. 明唔明我咩？因為 sodium ion 細粒啲，咁 sodium brom 你可以咁樣諗啦，可以上網揾下啦。So it is sodium bromide packing structure. Let us see with you that. The packing structure for that, it is more or less similar to sodium chloride. It's like this. Now I would like to tell you something like space Rayleigh model. In order to get to know, FCC, we've got to say centered cubic. So what is that? Now the structure will be this. Yes, something like that. Can you see that? So what is the special point about this? It seems like whether or not this red ball represents a metal ion. Okay, so if I have the red ball being larger, right, the whole structure will be a little bit different. So you get my point. But because for the red ball, it seems like filling the hole in between the blue one. 所以大粒啲咧，佢哋 packing 係會唔一樣。跟唔跟到呢度 ？This for question 2。有咩嘛？嗱 ，take a look question 3。Question 3， 呢個做叫你計empirical formula 嘅題目啦，都好似做過 N 咁多次㗎啦。咁啊，第一條問題問你咧 ，draw a label diagram。咁你話 label diagram 要做啲乜嘢咧 ？To show the experimental setup for preparing dry hydrogen in the soil。咁而家咧就想 問你駁呢嚿嘢之前呢個裝置係做乜，明唔明啊？所以係呢個裝置我要有啦。呢個裝置 dry hydrogen 嘛，咁即係要問兩點啦。第一樣嘢 how to produce hydrogen， 第二句 how to dry hydrogen。Okay, in order to score that 2 marks. Can you get a point? So the first setup you may think of is to simply we have got a fixed funnel with a long tube, we have got a round bottom flask, etc. We've got stopper, we've got some delivery tube, which would put in exit. What exit? 可以係 sulfur exit 啦，係做 exit 啦都得嘅。And I put the chemical inside as what? For example, magnesium zinc. Now, never put potassium, sodium. It's too dangerous. It's too explosive. Connect the delivery tube to somewhere. So what is that? Drying 啊嘛，有咩 dry 啊？有冇話都冇聽過嘢咯？攞咩 dry？
乾手啊，
乾手可以，所以咧你個裝置咧就要咁寫啦，你要畫個 bubble 落去啦。嗱，我會睇呢啲㗎 ，bubble 落去，跟住行翻出嚟。咁呢個就同我寫乾手，得唔得？跟住就同我箭嘴字翻啦 ，is dry hydrogen， 咁就夠啦。你明唔明啊？呢度第一分攞咗啦，第二分喺度做 dry。唔用 console 可以用咩咧？唔用 console 仲有冇其他？
anhydrous calcium chloride
係，如果用 anhydrous calcium chloride 嗰啲咧，你個裝置就唔係咁啦。你個裝置咧，你就要整 U tube 啦，或者要整一個咁嘅 tube 咁嘅東西啦，明唔明？有個 full pack 嘅 column， 跟住畫一紮圈圈啦，就同我寫 calcium chloride anhydrous 啊。嗱，唔寫 anhydrous 就冇分嘅，或者咩啊 calcium oxide 都得啦，係咪？因為佢 hydrogen gas 咧就冇酸鹼嘅，所以你唔使驚啦嚇，得唔得？即係呢個係2嘅替代方案，你可以畫呢個或者呢個，有冇嘢問？2分啊，類似嘅裝置啊，得唔得？咁你要同我講點 produce hydrogen， 梗係有原材料，兩個原材料一定要 label 咯。第二個咧就係、你睇個 dry agent 液體一定係固體啦，液體嘅左手邊，固體右手邊。有咩問 ？Explain why it is necessary to pass a dry hydrogen into the combustion tube before heating。點解未加熱之前已經要泵啲氫氣落去喎？咁做啲咩 ？To expel something。What is that？ 要拎走入邊啲嘢。
Oxygen 係嘛
？Oxygen. Where is oxygen?
Air.
Yes, to expel the air. Why? In afraid of an explosion. Why? Because when hydrogen is heated in air, they will get mixed with the air inside that will cause explosion. That means before you start the experiment, right, you'll be at risk. So expel the air first before you start the experiment. 2, through the combustion tube, even eating has stopped. 點解啊？哇！呢個問咗好多次㗎啦。點解做完個實驗熄咗個火啦，都仲要繼續 pass 啲 hydrogen？ 點解 ？To prevent what？ 又係嗰啲啦。
Oxidation 啊。
係啊 ，to prevent the hot， 嗱 ，this is the keyword， the hot metal Y formed already from being oxidized. Again, by the oxygen in air inside. 如果我 stop heating， 我咪 stop passing 個 dry hydrogen 時咧，其實空氣又走翻入去啦。咁所以咧又係啦，我防止翻去再次氧化嘅。今日到呢度，第2嗰度寫咗好多次嘅，1嗰個可能要認知下啦。第 C。Suggest how 又嚟啦，係 suggest how 啦，記住係同實驗有關嘅 experimental steps。 how to ensure that oxide of NOx has been with hydrogen completely。要重複個實驗咁點啊？直至到咁點做咧？加熱、冷卻同稱。嗱，唔好趁熱去做稱啊，因為趁熱去稱咧有好多嘅其他可能性嘅，因為有啲熱氣走上去咧個 mass 會變嘅，所以一定要冷卻先稱啊，直至到咩啊？佢哋個 mass 要係 constant， 要穩定嘅數據 ，constant mass of product is formed is obtained, for example. Okay, step 1 safety precautions for the experiment. Explain the answer. Safety precautions 有 wear safety goggles， 所以你都係。除咗呢個之外咧，原來氫氣咧，喂走咗出嚟咁點啊？喂唔會所有 react 晒噶嘛，你會做個動作會點啊？要燒過去。嗱 ，town gas 個實驗又係啦，hydrogen gas 都係嘅，你要燒咗佢，一分燒咗佢，第二分點解？防止咩？又係啦，有冇發覺啲解釋咧講嚟講去都係驚爆炸，係嘛 ？Is to prevent explosion when hot hydrogen gas, what happened to it is mixed with what oxygen in air。咁係好麻煩嘅，因為喺出邊個空間嗰度咧，你出嚟呢度啦，係嘛？如果呢一度有空氣，有氧氣，熱熱地就爆炸㗎啦。有人買 film 盤，咁 film 盤個原因係咩 ？film 盤嘅原因，咁你要話翻俾我聽啦。Based on experimental results, it determined empirical formula。你計到出嚟個 empirical formula 係咩 ？empirical formula 原因係點樣做啊？你要計 mole ratio 啊，計到出嚟係幾多？應該識㗎咯呢個。咁你要減數啦，一個207.2，一個係16.0，計翻佢哋真正嘅 mass 點計啊？呢個數減呢個數啦。How about the other one? 106.32 minus 102.48 equals 0.2398 to 0.240. Here comes 1 to 1. So you know that empirical formula of X oxide is what? YO. So you are going to mark this before you get the 2 marks. Questions? Now, question 4. Question 4 is a very authentic question. 2 experimental setup for investigating the phenomenon of frosting. They are shown below. So we have got that. The question comes and explain the 3 observations in tip 1. A blue color appears around the head and tip of the iron nail. Why? Take a look on tip 1. The iron nail is wrapped with a copper wire like this, but you may still find some blue region here. Blue region can find on here. Why? Can you get my point? Can you tell me what happened to this? Iron wrapped by copper. So which one is more reactive? Iron. Okay, so what is the hidden message? Iron, they will lose electrons more readily. Okay, then Cu. Okay, so what will happen? They will form Fe2 plus. Now, Fe2 plus, how does it relate to blue? So you are going to tell Fe2 plus ions react with the hexacynyl ferrate 3 to form a blue complex. So that's why I would say that there is a blue color appears. Is that clear? For tip 2, why would they have colorless gas bubbles? What is that gas? So take a look at the gel. What can be found inside that makes it colorless gas bubbles? 你覺得係咩？我哋唔知。It's hydrogen ion. It's a gel. It will accept electrons, lots. Although we want to get a gain, electron lost by the iron, and what will happen? And they are reduced to colorless gas bubbles of hydrogen gas. So you remember, you are going to relate, for example, blue complex to the blue color here, colorless gas bubbles to relate to this. So you are going to use this for explanation. So what is the equation? The equation should be 2 hydrogen ions, AQ, plus 2 electrons to form hydrogen gas. 3, pink color. Why is that any pink color? Yes, that is the third equation. The dissolved oxygen and water in the gel, what happened? They will gain the electron lost by what? Iron, and are reduced to form what? Hydroxide. Well, but how come hydroxide will turn pink? What reacts with what? It turns phenolphthalein pink. Okay, so remember. So you are going to relate pink, phenolphthalein, hydroxide, pink color. You're going to relate that. Of course, for this first sentence, they should become with the equation. What is the equation? Now, first one, iron to form iron 2 plus 2 electrons. Second is hydrogen to form hydrogen gas. How about equation? Oxygen. As I said before, right? Water. What's next? Electrons to form hydroxide. Do you know how to balance the equation? So that equation you should have memorized it. That appears in the book, Rustic. Explain the 3 observations to 2. The 3 observations. The compare with 1, colorless gas bubbles evolve more rapidly. 比較2同埋1出泡出得快啲，唔係多啲啊，係快啲。So what is the difference between the 2? The combination is different, right? Iron nail wrap with copper or iron nail wrap with magnesium. So you're going to compare magnesium and copper by its reactivity. It's more reactive than iron. Okay, so how does it relate to the speed of reaction? The rate of the release of electrons from Mg to Fe is faster or rates, right? Higher rates. 所以咧，要一個比較就係咩？reactivity。 losing electrons 嘅速度係快啲，得唔得？呢兩個係重點字眼，呢一定要見到。So this the reaction occurs faster. So the formation of the hydrogen gas in chip 2 is higher. 點解啊？因為條式話咗俾你聽嘛。Two hydrogen ion to form two electrons to form hydrogen gas。所以釋放嘅 electrons 嘅嘅時間係快啲嗰陣時，意味住咪出泡咪出快啲咯。So this is what you talk about question 1. How about question 2? Question 2 is something about what substance appears on the surface of the magnesium river. So what is that what substance?
Magnesium oxide 啊。
係啦，學埋嗰個acid alkaline 嗰個咧，你會明啦。咁 Mg 溶啊嘛，咁 Mg 要做啲咩嘢咧 ？So Mg they will loses electrons to form Mg2 plus ions. So they will be help supported by writing the equation. Mg to form Mg2 plus 2 electrons. 咁第二句咯喎 ，Mg2 plus ion will happen. They will react with what can I find? It's a hydroxide, right? Around the iron nail to produce white what? Precipitate. So indeed it is precipitate. So of magnesium hydroxide. Can you get a point?仲未有輕機啦，成日輕機，去邊啊？呢度係啦，見到嘛？呢度 to produce the white precipitate of MgOH2。咁原來係呢條式嘅啫 ，AQ 啦，二正 plus 兩個 hydroxide to form Mg bracket OH2 solid， 明唔明啊？即係你將你個 alkaline 嗰個咧套埋落去啦，跟唔到？到最後咯喎，第5條 ，one use of sodium azide， 哇黐線咁點明嘅 ？is to make lacto azide which will use a detonator for the explosion. Lacto azide can be made by reacting with A2 lacto nitric solution sodium azide solution。你見到咁，佢都要你寫 equation 啦，係咪 ？By reacting 乜乜啊嘛，咁即係話咧呢兩嚿就係 reactant， 係咪 ？reactant。咁而佢嘅 product 係咩咧？喺邊度啊？有 lacto azide 做咩？呢個 product 係嘛？咁但係喂唔齊嗰啲嘢，咁唔緊要啊，寫翻出嚟先。Lacto nitric solution 加咩咧 ？Sodium azide，sodium 係有得抄啦，係咪 ？Sodium azide 兩個 NaN3 solution 變咗做 lacto azide， 哇黐線啊！呢個寫唔掂。Na 啊，好彩呢度有得抄。Pb bracket N3 solid， OK， 整炸藥啊嘛，點會唔 solid 咧？咁你再加咩？咪爸爸一半，媽媽一半咯，係咪啊 ？Lacto azide 嘛，咁剩翻佢咩？咪就係嗰兩個咯，見到？呢支 sodium nitrate 啦。用喺水嘅，所以寫翻2啦。AQ。What method will you use to separate the lacto A side from the reaction mixture. 嗱，留意住呢啲有咩方法提取出嚟？用咩方法 ？AQ solid AQ， 我攞佢攞咩方法？逼你要串呢隻字咯 ，filtration 咯。可能要你畫呢部 set 嘅喎，係咪啊？嗱，翻去諗一諗，有機會又叫你畫呢部 set up 㗎啦。What method 唔使，但係我可能話要你 draw the 呢部 set up， 咁你要識畫啦。曱甴。第三，10 gram 嘅 lacto nitrate 同5.20 gram 嘅 sodium A side 就喺 solution 啦 mix 咗之後 ，produce 到幾多？哇耶！就係問嗰個啦，係咪啊？就計翻呢條式咯。其實係最唔慣咧係呢嚿咁嘅東西，唔知乜。不過咧，唔知乜有唔知乜嘅計法，因為咧你照做翻平時計 mole count 嘅嘢啫，係嘛 ？So what you're going to do is to write down number of moles of lacto nitrate and sodium A side respectively. You are going to write that two information, right? Can you get my mind? So what we get, the first one is 10.0 gram over 1.2 gram per mole. The other one is 5.20 gram over is molar mass. What is that? Sodium A side 幾多？呢個點計啊？3個，就問計到俾我。
65啊，
好幾多？咩啊
65
？65.0，好，佢哋嘅摩數係幾多啊？呢兩個
0.08 mol
0.0800。三式 fact. How about the first one? 0.0302 mole. So which one is in excess? Which one is the limiting reagent? Come on, which one is in excess? Which one is limiting? Okay, this is lacto nitrate. It is what? So if you don't understand, now let me put it this way. I write it in detail. So in case I've got 0.0302 mole of PB nitrate, they would react with how many moles of sodium A side? Just 0.0604 mole of sodium A side. Can you get my point? Thus, which one is in excess? Sodium A side is in excess. Okay, which means that lacto nitrate is limiting. So you use the data from lacto nitrate, this one, to project the mass of lacto A side to be formed. So number of moles of lacto A side is also 0.0302 mole. Can you get my point? 都係攞佢個準啲嘅數，呢個數唔準㗎嘛，就係用個準啲嘅數，用盡晒嗰啲。So we may get the mass of lacto A side produced 0.0302 mole I don't want mole, but I want mass. So this is molar mass. So what will you get? What is the mass? 8.79 gram. So you may get what 8.79 gram of lactose acid is produced. Can you get a point? So if you go back, recall your memory about this question, you may find that this machine is rather complicated because the questions ask for something more nasty thing is about the limiting agent, which one is in excess. How do you know? We have to calculate this. Now, from the questions, it is they will give you enough clue. 點解咧？因為題目講咗㗎啦，佢話係10 gram， 見唔見到10 gram 嘅10 gram 嘅 lactose nitrate 就 react with 5.2 gram 嘅 sodium acid 啊嘛，冇理由咁好死嘅，個 reactor 兩個都俾晒 mass 嘅。如果你見到佢係咁咧，就意味住一定要計下其中一個係冇 react 晒，冇 react 晒嗰個你就飛咗佢啦，唔好攞呢個數嚟 project。咁點計都錯㗎，你要用翻啱啱好 react 嗰個數，即係腸仔之雙蛋嘅問題啊嘛。咁你搞掂咗腸多定蛋多先啦，即係邊個有整啦，咁你先好計，得唔得？咁我哋回顧翻咧，你話問我，咁今次我考翻啲 exam 會唔會有見翻呢啲題目咧？答案係會嘅，你明唔明啊？所以咧，你係幾大劑嘅，因為我仲未講 SNL 同埋㗎。所以咧，你後邊下一堂咧有5條長題目咧，就講 SNL 啦。咁你真係要翻去做啦，明唔明？你呢兩日時間你做埋後邊嗰5條，令到大家咧去明呢度發生緊乜事。嗱，下個禮拜嚟緊兩日後啊，2日後再講，得唔得？咁我哋咧去到呢度問一問先，有冇同學有問題？有冇同學有問題呢度？回顧下咯，即係話 long crack 咧，我可以我問 book 1A、book 1B 嘅話咧，問得比較多嘅題目係 book 1B， 唔好花太多時間喺 book 1A 度，得唔得？咁但係 book 1A 係咪唔會問啊？答案唔係嘅，係會問，不過 long crack 問得少。long crack 咧，我哋就會問 bonding 問得多，係咪見啦？如果 metal 嘅話咧，我見到呢幾系列嘅題目咧都會出現啦。如果可能佢問你 reactivity 啦，比較下邊個 molarity 啦 ，rusting 啦，或者叫你計數。計數嘅話有2種計法，係計咩啊 ？empirical formula、molecular formula 嗰啲啦，或者係 mocap。mocap 咧又留意下咩咧？如果條題目一開始俾咗你兩隻 reactor 都俾晒啲 mass 你咧，你小心啲中伏啦。佢係要你去計下邊個係 limiting reagent。邊個 in excess， 你先推斷到 product 有幾多嘅？咁而嗰個reactant 咧係要limiting 嗰個，你先可以 project in excess 嗰個冇得 project， 跟唔跟到？有咩嘢問啊？點啊？有冇發覺自己應該都零眼咁啊？點啊？0到10。自己喺個 chat box 度話俾我聽，覺得自己係0，會唔會啊？嗱，你係時候真係要再做下啲練習啊！你搞唔掂嘅話咧，咁我會呢個假期去跟進，我揾翻嚟，要你我有份10P 㗎啦，我唔理㗎啦。鄭學明咁快戴頭盔啊？安德你話5上寫。計進都負2，係啊 ，long cat 唔易答㗎，你 feel 唔 feel 到啊？係嘛 ，long cat 真係唔易答。咁所以咧，今日就去到呢一度先 ，OK？咁我哋後日再講，記住做埋後邊嗰幾條，拜拜。